the bronchial circulation is actually one of the part of circulations that we have discussed. It's a small circulations, but whenever we talk about there, as I said, there are the most two important big circulations are going to be your pulmonary circulations and systemic circulation, right? But your respiratory system has two circulations, which is the pulmonary circulations and the bronchial circulations, and we have to talk about what that is, okay? Okay, this drawing, like, okay, what is it? It's anatomically it's not correct, obviously, but functionally I cannot do this, so it can make more sense as we go over, right? So basically, like here, just quickly, if I talk about this, I made this a trachea, and this is divided into bronchus right here, and there's a different alveolar sac right here, right? And then obviously, then because really what happens is that your heart is actually located in between the two lungs, right? It's actually at the level of medial mediastinum, but then what I just took the heart out and then I separated it out. So I put the right heart here, and then your left heart is going to be there, okay? And then here, this is going to be my right atrium right here. The right ventricle is going to be this one, right? And then this is the bringing you deoxygenated blood, mixed venous blood. Okay, let's just write it down. Mixed venous blood. Mixed venous from your systemic circulations through the inferior vena cava and is draining into your right atrium. And this is from like superior vena cava right here. It's bringing from like blood from all those head and neck areas, all right? And then I kind of just do this picture too. It's bringing blood from all the head and neck areas and then draining to the right heart, and that's so the superior vena cava, right? Now, what we have to talk about is that, and then this is going to be this is a pulmonary artery. So remember, I draw this in blue. The reason why I draw this in blue is because it's bringing deoxygenated blood here, right? This is bringing deoxygenated blood. And you said, what is the partial pressures of oxygen is here on your pulmonary artery, which is about 40 millimeters of mercury, right? And then here, the partial pressure of carbon dioxide is about what? About 45 millimeters of mercury, right? And then if you want to know the percent saturations, we also talked about what is the percent saturations at the mixed venous blood. It's like your hemoglobin, right? It's like about like 75% saturations if you are in a normal level. If you exercise, that's gonna change, right? But it's about 75% saturated, okay? That's what you get to see in the mixed venous blood, right? And then when we talk about the gas exchange, we'll talk about the total oxygen content and all that stuff, but today let's just focus on the bronchial circulation right now here. Now, and then this in a pink color, I drew that. This is where the mix of exchange are happening, okay? Gas of exchange are happening. So basically what happening is that the carbon dioxide is going out. Let's just make this a carbon dioxide is going out, and let's just picking the oxygen down here, okay? And then when the blood, when your blood leaves the capillaries, what's going to happen is like whenever blood leaves the capillaries, there are a couple of parameters that you have to know. One is that when the blood lives in this capillary, your partial pressures of oxygen right here is going to be what? Because when it's going to be exactly, it's going to be 100 millimeters of mercury, okay? When it leaves the capillaries, right? And then what is going to be my partial of carbon dioxide is going to be what? It's going to be about 40 millimeters of mercury. Okay, it makes sense because remember, it's always the pressure goes high to low, right? It's a 46, 45 here, 45, 46, it went down, right? And then when it comes out in the capillary, it's 40. So if my partial pressure of oxygen is 100 millimeters of mercury, then what is going to be my percent saturation? It's also going to be 100% saturations. Okay, so now, when the partial oxygen leaves the capillaries, I'm talking about this, the pulmonary capillaries, okay, when it leaves it and it goes to the pulmonary vein, this is my pulmonary vein, right? Because this pulmonary vein is actually carrying oxygenated blood, that's why I draw in the red. Don't confuse, whenever you see the red, okay, don't think that it's artery, because this is a different thing here, okay? So, again, I'm going to repeat this. The partial oxygen is 100 millimeters of mercury and 100% saturations at the when it leaves the pulmonary capillaries, and from the pulmonary veins, this is going to drain in the left atrium, right? This is my left atrium right here, and this is going to be my left ventricle here, and then this is going to be my aorta. All right. Now, we have been talking about this for a while, right? Now, but we have to talk about what is bronchial circulation is. You know, the bronchial circulation is actually part of systemic circulation. What does that mean? That means is that, you know, this bronchial circulation basically means bronchial arteries are actually carrying oxygenated blood, okay, and that is actually supplying to the conducting zones, okay. I'm writing down the conducting airways, like all those conducting airways, you know, like all those bronchus, main bronchus, right, all of them, it's supplying that areas, okay, and also it is supplying to those hilar lymph nodes. It's also supplying there, okay. It's also going to give branches to your, a little bit of a supply to the esophagus too, okay, and also it's going to supply to the, obviously, visceral pleural too, okay, of your lungs. So what is it doing is that from your bronchial artery, it's a part of systemic circulations. The reason why systemic is because it's part of systemic circulation is because the bronchial arteries, it is coming from your aorta. Actually, it is coming from your aorta. Where it is coming from aorta is the two things. Like if I see, look at this here, if I make this is called, okay, let's try. This artery. It's we said it's a left bronchial artery, okay. This left bronchial artery is actually arising from the thoracic aorta, which is a descending, if you want to be very, very clear, it's a descending, because it's a descending part, descending thoracic aorta, okay. That is what this left, your brachial artery is coming, and that, because of that, is bringing oxygenated blood, okay, oxygenated blood. All right, and then you're right. This is my right brachiocephalic veins right here. Sorry, your bronchial. Sorry, as a bronchial artery. Why am I confusing with brachiocephalic? But this right bronchial artery is actually, it's arising from about, like, it's not exactly coming from the thoracic descending aorta. Actually, it is arising from this intercostal artery. It's about, like, maybe we'll say this as an intercostal artery here or here, and it's like maybe third or fourth intercostal artery. Okay, it is arising from. Maybe it could be third, it could be fourth, okay? So it's arising from the third or fourth intercostal artery, and this is my right, okay, I wrote this, right bronchial artery, right? And remember, right and left bronchial artery, that's just why, because it's arising from those aorta, okay? And because of that, we call them as the parasystemic circulations. And what are they doing? They're bringing oxygenated blood, okay? These arteries are bringing oxygenated blood, okay? Now, these are, and then as I said, these are supplying to all this, like conducting airways, hilar lymph nodes, esophagus. Maybe it gives, and the visceral pleura, it gives, is supplying there. It's carrying oxygenated blood right here. So if I see this, if you follow me, your left bronchial artery, it comes and it supplies all this left part of your, okay, the left side of like your bronchus, okay. Because if I make this, okay, these are going to be my. This part is going to be like, let's say, right lung here, and this is my left lung here. So it's basically supplying the left part of the lungs, right? So left part of the lungs. And if I make this, look, if you see all this pink color, what happens is that there are capillaries, right? These are going to be breakdown in capillaries. And then after that, what's going to happen is that this will become brachiocephalic. Then after that, what's going to happen is that it will convert into venules and veins, right? And these are my bronchial vein now, okay? Now these are going to be my left bronchial vein, okay, left bronchial veins. And then now this left bronchial vein, and then what is the other thing is that here, if you bring this right bronchial artery, it's going to go and supply the right side of the lung, right? It makes sense. And this right of the lungs, obviously, is going to be capillaries, and it's going to supply to the right side of the lung. And remember, I made the this alveoli, which basically means there are a lot more. There are 300 million alveoli, but these is divided into, remember, like it's your second, the primary bronchus divided into three, like secondary lobar bronchi. That's what I try to draw here, right? So what happens here is that it supplies all those places, visceral pleura and all that stuff. And then after that, what happens is that if there's a right bronchial artery, it's supplying oxygenated blood to this area, then after that, what's going to happen is that they also have a bronchial vein, actually, right? That right bronchial vein is this one. This is carrying a deoxygenated blood. Now this part right here in the blue, this is carrying deoxygenated blood from the bronchial circulations, okay? Your left bronchial, okay? So this left bronchial vein, what is it going to, it is carrying deoxygenated blood from the left side of the lung, and what is it going to do is it's going to drain into this guy right here. And what is this guy? This is left, right? It's going to drain into hemiazygous vein. Because you remember the hemiazygous vein, it's open at the T9 level, if you want to remember that. It's a hemiazygous vein. This is a hemiazygous vein, right? And then this hemiazygous vein drains into a zygous vein, okay? That's what happens. And then if you look at this right side of the lung, that brings it supplies oxygenated blood from the right circulation, and it brings deoxygenated blood from the right bronchial veins, and then goes and all the way drains into azygous vein, right? And from the azygous vein, what happens? This azygous vein drains into your superior vena cava, and superior vena drain into right atrium, right? But this is what normally should happen, right? And it does, but life is not simple, life is complicated. So what really happens is that, when these guys are passing, when he's being in deoxygenated circulations, what is going to happen is about one third of like this deoxygenated blood that actually get drained into your right atrium, okay? Only about one third of this gets drained into drains into the bronchial venous blood. The bronchial venous blood drains into your right heart. What happens to 2/3 of the blood? The 2/3 of the blood, what happens when they are going, like what happens is that, like these guys get anastomosis with this circulations, like this, all these circulations, okay? When they get all this anastomosis, the 2/3 of those, the bronchial venous blood, they straight drain into, let's just make this, okay, let's make it into this, let's make this a blue. They straight drain all this venous blood right here from the both the bronchus venous blood. It drain straight into my pulmonary vein right here. Okay, because of the anastomosis vessels, what happens is that these guys drain straight into my bronchial vein right here. Sorry, my pulmonary veins. Okay, now what happens is that, look, when it straight drains into my pulmonary veins, what happens? That means, what is this? This is carrying what? Deoxygenated blood, right? This is carrying deoxygen, and that the 2/3 of those deoxygenated blood is straight drains in my pulmonary veins. When it was 100, like what happens? Oxygen was 100%. The partial pressure oxygen was 100 millimeters mercury, and the saturation 100%, right? But remember, when there is a mixing of this deoxygenated blood, okay, which is high in carbon dioxide with the oxygen, what's going to happen is that going to reduce your partial pressure oxygens and saturation? Yes, it does, right? So what happens is that when in your pulmonary veins, okay, this partial pressure oxygen right here in this level, what happens, this partial pressure oxygen drops down, and maybe it becomes like, let's say 97 millimeters of mercury, and then this partial pressure oxygen maybe goes down to and becomes here, let's make this, it becomes like maybe like 98 or 99 millimeters of mercury. We'll just make this one, right? That's what happens, okay, around that number. Because of this shunting, we call them shunting, and the reason why we call them a shunting is because your mixed venous blood, your deoxygenated blood is directly mixing with the oxygenated blood, okay? That phenomena is known as called shunting, okay? But this is, okay, normal, like physiological shunting, okay? Whenever there's a mixing of your deoxygenated blood, oxygenated blood, then we call them as a shunting. And this part of the circulation is a physiological shunting that happens normally, okay? Physiological shunting, and that drops the partial pressures of oxygen 97 and 98. And with that, it doesn't really affect that much because it has a really high pressure of oxygen still carrying. So it is still able to, systemic circulation is still able to get all those organs are still able to get enough oxygens, all right? And this is, as I said, we call this as a physiological shunting, okay? And there are different types of shunting there. There's anatomical shunting and there's a physiological shunting, okay? Anatomical shunting is, let me just quickly talk about that too. Anatomical shunting basically means is like, okay, it has to do with structural basis. Structure, what does that mean? That means like, let's say, what is this, atria, right? If you have the atrial septal defect, if you remember atrial septal defect, okay, then what's gonna happen is that you have a shunting of a blood from the right to left, okay, and that is basically structure basis, right? If you have shunting up from the blood, because really what happens is that from the right atrium it goes to right ventricle, right, and then through the channels, and that's usually happens, right? But if you have atrial septal defects, what happens is that it can go to the right atrium, can go to the left atrium, right? So this is, and then it can mix this with the, let's say this is my left atrium, it can mix it with the left atrium, and that is oxygenated, right? Oxygenated blood, and that can bring the oxygen, possibly oxygen down, right? That is called anatomical shunting, okay? And then physiological shunting, okay, this one is one of the part of physiological shunting with the normal conditions. There are other, like for example, like you collapse lungs, or even in pneumonia, okay, you could have the physiological shunting. The reason why is because, look, if your airway is collapsed, what's going to happen? If this is collapsed, let's say this is collapsed. If this is collapsed, then what's going to happen is that all the blood that is coming from here, it's going to go to other directions, right? So because of that, it could see that in pneumonia or even in collapsed lungs, you could able to see the physiological shunting, okay? And we'll talk more than in pathology when we get there. But this is a normal coming back to this is a normal physiological shunting from the bronchial circulation, and that drops the partial pressures of oxygen 97, about like 97, okay? Now, there's one more physiological shunting that we haven't talked about, and that is, because we're talking about shunting, that is from here. Look, this is aorta right here, right? And then there are some, and then look, these are coronary arteries, right? These are left and right coronary arteries. For this one is left coronary artery, there's a right coronary arteries too, okay? That is bringing oxygen and blood, right, to my ventricle, correct? Okay? So this is bringing this is my, let's say, left coronary artery. It is bringing the oxygen in your blood here, right? But there's some actually blood vessels there, okay? They're very, very important blood vessels. What they're usually heavily found in right atrium, but there are also some located in left ventricle. And phonetically, they call this as this left ventricle. These are called smallest cardiac vein, okay? Or they're called Physio vein, okay? And it's because, and this name comes from it's a German German name, it's a German scientist name, okay? The Physio veins. And as I said, phonetically they call these also like vessels of like WEAR vein. These are smallest cardiac veins. And what these guys do is that these guys carry deoxygen in your blood, right? And what happens is that these guys, the smallest, they drained like some of the venous blood into your oxygen. So remember here, what is this? The partial pressure oxygen is right here is what? We'll just write down, it's about like 97 millimeters mercury. Saturation is about like 98 millimeters mercury, right? So if this is drained here because of Physio veins, what's going to happen here is that Physio veins, what's going to happen is that it's going to carry deoxygen in your blood right here, right? So it's going to carry deoxygen in your blood, and then it's going to mix with the oxygen in your blood now. This is also another type of physiological shunting here. And because of that, what happens is that whenever it leaves the left ventricles, whenever in the way it comes here, what happens is that the partial pressures of oxygen is dropped to maybe like 95 millimeters of mercury, okay? And then maybe percent saturations of oxygen is about like 97 millimeters of mercury, okay? And this is usually the numbers that that is going to your systemic circulations, okay? So again, there are two types of physiological normal shunting that we get to see here. One is from the bronchial circulations, okay, because the 2/3 of the bronchial deoxygenated mixed venous blood directly drain into the pulmonary veins, and that decreases the partial pressure of oxygens about 97 millimeters of mercury, okay? And then based on that, also because the partial pressure, because remember, partial pressure of oxygen, that determines your saturation level, right? And then whenever the partial pressure of oxygen goes down, your saturation also goes down, but the saturation goes down about like 98 or 99%, okay? Then after that, there's also another shunting that happens when the Physio veins actually drains from your left ventricle. It drains into your arterial circulations, and that mixes the deoxygen, that's carrying a mixed venous or deoxygenated blood from your left ventricle. And what happens is that mixes with the oxygen in your blood, oxygen blood, the arterial circulations, and that also drops your oxygen, and usually it's about like 95 millimeters mercury, and then the saturation level will go down about 97 millimeters of mercury. And remember, it doesn't affect the carbon dioxide, because carbon dioxide still here is PCO2 is about what? 40 millimeters of mercury on my arterial side, right? This is what happens. And then on the level of the oxygen level partial pressure of 95 and saturation 97 millimeters of mercury, this is what it goes for systemic circulations. And those organs, all this, like from your brain, right, your head, from your neck, from your head and neck, which is and then also like all the kidney and your scalp muscle, your skin, your GI systems, they would able to. This is what they will get. Okay. One more thing. if you want to be very, very clear, like how much like cardiac output that your bronchial circulation gets, it's about like 2%. If you want to remember that. Okay, 2% of cardiac output that bronchial circulation gets. All right. Now, let's just write down a little clearly. Okay, bronchial circulations. That's what it gets. Now, all right. This is about the bronchial circulations. All right, guys. This is all I have for you guys.